Hello everyone, it's your host Aus back again with another Blender tutorial. Today we're gonna go over how you can make this effect using Blender new simulation nodes. Well, let's dive right in. So we're gonna divide the effect to 4 different steps. Step 1 is gonna be making a 3D grid. Step 2, we're gonna convert every vertex of the grid to a point. Step 3, we're gonna tell Blender which point is inside the geometry and which point is outside, and we're gonna delete the points that are outside the geometry. Step 4, we're gonna give the points some velocity using simulation nodes. So let's start off by deleting everything except the cube. Let me just turn on my screencast key and adjust my view for a little bit. Start by making a new geometry nodes group. Let's call this object 1. Click the pen to pin the group. Now what you want to do is make a 3D grid, which is just a few subdivided planes stacked on top of each other. And to do that, you first need a curved line and connect the curved line to an instance on points. So every point of the curve will instance a grid. Set the instance object to a 3D grid, and you want to resample your curve to control how many points on the curve. Later these points will be grids. Let me just adjust the position of these nodes. And now if you change the number on the resample curve, it will change how many grids you have. And you will control the subdivision of the grids by controlling these 2 parameters. You see, you can change the scale of the grids. And also let me just turn on my wireframe mode so you can see how many vertices we have. First you will connect the resample curve to a value, set the value to 10, and connect the value to vertices x and y. So on the x and y and z, because we are controlling the resample curve, you'll get the same amount of points. Next, to control the scale of your grid, you will connect the end to a combine xyz. You will have another combine xyz connected to the start. And you will need a value node to control the scale of your grid. Make this a 1 and connect it to both the z of the start and the z of the end. Get a map node, set it to multiply, and multiply the end and the start by zero point 0.5. Make one of them 0.5 negative and the other one 0.5 positive. So when I set the value to 1, the start point will be negative 0.5 on the z-axis and the end point will be positive 0.5. So it will keep the grid centered in the middle of the world. And now you want to group all these, but first you need to connect your scale value to the scale of your grid. So when you adjust this value, you will not only control the scale on the z-axis, but also the scale on the x and y. Let me just adjust these lines. So G to grab and move this. Let me just grab and move this over here. And move this point over here. And before you group everything, you see this value control the subdivision of the points. Before you group everything, don't forget to realize your instance by realize instance node. Now we're gonna group all the nodes we've just made. So select everything and use Ctrl G to make a new node group. You wanna control the scale and you wanna control the subdivision. Now click N to go to the side panel, go to group and call the first value scale and the second value, let's call it res for resolution. Now you see me connecting one more value, so connect the x to both the x's on the combine xyz to control the location of the 3D grid on the x and also do that for the y. Now you can control the location of your 3D grid on the x and y. After you're done naming your groups, you want to click tab to exit, click on your node group and name it. We're going to call this one 3D grid. You can also give it a color if you want. go to the side panel and go to the node and click on color. Now if you're done giving your node group by color, set the subdivisions to 20 and the scale to 1. Now if you preview this, you'll have a 3D grid. See? Let me just turn off my wireframe mode. Now let's connect this to the geometry output. Now what you want to do is convert every vertex of the grid to a points. To do that, you'll use a mesh to points node. And now you want to readjust the scale. You make it a scale of 3 and the subdivisions of 50. After that, go to your 3D view and click tab to go to edit mode, shift Z to go to X-ray mode, and you want to delete your cube geometry and add a Suzanne monkey. Just the default Suzanne monkey, don't change everything. Next step, you will need to turn off your geometry node and add a subdivision surface. Set the subdivide surface to 1 and move it above the geometry node. Don't forget to turn on your geometry node. What this will do is subdivide the surface of the monkey before it enters to the geometry nodes. Next step, we need to tell Blender which point is inside our geometry and which point is outside our geometry. Let me just explain this real quick. Now every 3D object has faces, and each face has an arrow that points outside, an arrow meaning a vector. And it also has a position in the middle of the face. So if you subtract the position of the face from the position of your point, you'll have a vector that points from the point to the face. If you compare that vector, the green one, with the normal of your face, the red one, if they're pointing the same direction, that means the point is inside your geometry. If they're pointing in the opposite direction, that means that the point is outside your geometry. And to do that is really simple. It only takes a few nodes. First, you need to connect your monkey geometry to sample nearest index node and connect the position to the position. So this node tells Blender to give you the ID of the point that is near your monkey geometry. Next, set this to face because we need it to be near the face. Next, you want to sample index. So now you know which point is near your geometry. You need the position of that point. So connect the same geometry of your monkey. Set this to a vector and connect the position. So you will get the position of the point. Next step, you need the normal of your geometry. So duplicate the sample index node and connect the normal to the vector and connect the same geometry and the same index to it. So just connect the vector to a normal node and connect the geometry, the same as with the other one. So the next step is to get the arrow that points from the point to the face of your surface. And to do that, you use a math subtract node and subtract the position of the face from the position of your points. So after you get the vector that points from the point to the surface, you need to multiply it with the normal of your face using a dot product. So basically, if they're pointing the same direction, the dot product will give you a 1 value. If they're pointing in the opposite direction, it will give you a 0 value. So connect this to a delete geometry node to delete the points that are outside. Let me just check everything. Get a delete geometry node and connect the value of the dot product to the selection. And you will need a map range node, and you need to invert it, so make it from 1 to 0 to only delete the points that are outside, not the inside. And now you want to narrow down your selection, so make it from 0.01 to 0. Now it basically just works. It will delete every point that is outside your geometry. So let's turn the resolution up, make it, let's just make it 60 or 70 or something like that to get more resolution to work with. Now adjust the radius of your point. Don't make it too big or too small, just something that would work for you. Now if you go to edit mode and you delete your monkey Suzanne and you add a torus, it will do the same steps. It will go over, make the points, and compare the points to the geometry and delete the excess points. So it will work on any geometry. Only the geometry normals need to be set right. So if you invert the normals of your geometry, it will not work. Now let's group everything. So select everything, Control G, and you want to control the two values on your map range. I don't see why you need them, but just in case you do. Let me just make this easier to look at. Get this over here, grab this, move it over here. And now after you're done, you need to press tab to get off the node group. Scale it for a little bit and let's call it is inside. So it will give you a value if the point is inside. You need to grab this, put it over here, grab these two, put them over here. So you just know what you're working with. So the next step will be the simulation. Before the simulation, you need to store name attribute. So store name attribute tell Blender to remember the position of the points in that instance or in that time. So you need a store name attribute before your simulation nodes, and you want to store the position of the points. So Blender need to know these points used to be a monkey. And to do that, you add a store name attribute node before your simulation nodes, and you set it to vector and you connect the position. And you also want to name it. Here I'm going to name it rest pose. So it's the position of rest. I don't know if this makes any sense. And next step we're gonna want to save another value, which is the start pose. So at the frame start, it will remember where the point is, and after you displace it, it will get a new position. So let's first add another store name attribute and also set it to vector and also connect the position to it. Just call it start pose. And after you've done that, Blender will remember the position of each point in the start of the frame. Let's say that we've displayed these points in the middle. After we've displayed these points, we need to calculate the velocity. So get another store name attribute, and you want to call this vel to velocity, and you want to connect the position. Connect the position and connect the position to a subtract node, and you want to subtract the start position. After you subtracted the start position from the current position, you will get a velocity vector, and you will use this velocity to move the object. So if I displace the object, I expect these objects to keep moving for a short while or a short distance and then stop. And to do that, you will use the velocity. But the velocity decrease over time so they don't keep moving forever. So use a scale node and set it to 0.9. So each frame it will get 0.9 of its velocity of the last frame. So we'll multiply the last frame by 0.9. For each frame it gets multiplied by 0.9 till the point it stops. And now let's use the velocity. So make a set position node, connect a name attribute, and select your vel attribute. So now let's see if the velocity vector works. So get another set position node, and now we're gonna make our third and last node group, which is the switch node. So get a switch node and connect to the true and noise texture. And you want a vector math node, vector math, and set the vector math to subtract and subtract 0.5, and you will need another vector math node, set it to scale. So make the scale 0.1 and make the node scale 1, and now when you play your animation and click the switch, it will switch on the noise. When you click it again, it will turn off the noise. So now let's just quickly test it. So let's make the animation 1000. Click spacebar. Now switch on the noise. And when you switch it off, they keep moving for a little bit and then stop. You can control how much the point keep moving after you turn off the noise by controlling the scale of your velocity. Now you want your points to rearrange themselves in the shape of a monkey after you apply the noise. And to do that, you will use the rest position that we saved. So now each point know where it should go. So to do that, let's call this correction vector. You just need to duplicate your velocity setup and call it correction. And instead of the start pose, let's just use the rest pose. Instead of positive scale, we don't want them to move away from the rest pose, we want them to move to the rest pose. So make the scale negative, make it a small value like 0.1. And now connect your velocity and your correction to a mix vector node, and connect the mix vector node to the velocity. And you need to set the mix vector node to a point of 1. If you set it to more, the points will move quickly back to their position. So this controls the mix between their velocity and their correction velocity. Okay. So next step, let's just test it. We just adjust these for a little bit. Now go back to your switch noise, adjust these, and you want to now group your switch noise. So select everything, Control G to group, and you want to control, first you want to control the switch, now you want to control the vector scale of your noise, and you want to control the noise scale, the noise roughness, and the noise distortion, and the noise detail. And now click tab to go back to your graph, and you want to name this node group we've just made. Let's call it switch noise. So it's a noise that you can switch on and off. Pretty simple, huh? Now play your animation again and click on the switch. Click on the switch, and when you turn off the noise, the points move back to their original place. I need them to move faster, so I'm gonna make this more powerful. So 1, let's see if 1 works. Go back to your switch noise. When you switch on the noise, when you turn it off, it will move back to its position pretty quickly. So go back and adjust the value to your liking. I think this is too fast. And if you go back to your nose, set it to 4D and connect time, seconds, to your noise, you'll have an animated noise which looks better in my opinion. It can also slow down your PC. So now, as you can see, the effect is basically done. And now the points move back to their original place. But we don't want that. We want them to move to a different place to form a different object. Let me just adjust the resolution again. Now the next step is we're gonna get the geometry of the second object, and we're gonna do the same thing with the deleting the points that are outside the geometry. And to make the points, the monkey points, go back and rearrange themselves to form a different object, we need to first tell the monkey points to remember another position, another rest position, which is going to be the rest position of our second object, which is the torus. So add a torus, drag your torus and drop it into your node graph. Move it to a fancy position first. And now what we're going to do next is just do the same thing we did with the monkey. So you will take your 3D grid that you turn into points, and you want to connect your 3D grid, the same 3D grid. It needs to be the same. Now what you do is you just duplicate the is inside and the delete geometry and the mesh to points node. And you want to connect the is inside to your new geometry, which is the torus. And after that, you need to connect your 3D grid to this points to mesh, so it takes the same grid and turn it to the same points, and it will delete geometry or delete points if the points are now inside the torus. So if you preview this, you'll see that it just works. So now you just tell Blender to remember these points that are forming a torus and store that information on the point or the points of the monkey. So now you need to connect a sample index node. So this node is just telling Blender to get the position of each point of the torus. So now you need to control the index, which means that you're telling Blender to calculate how many points are inside the torus, and for each point that's inside the torus, get its position and store it. Well, we still didn't store it, but we're just getting it at the moment. We need to connect the domain size to the delete geometry of your torus. Right now I'm connecting it wrong. Now let's store this information. So duplicate your store name attribute and set it to rest pose. Let's call this rest pose 2. And you want this vector to be connected to this one. So right now it doesn't store any information. If I disconnected this and set this to a random value and set this to a 1000, maybe let's just make it 10,000, so it will get the location of 10,000 points that are random. So it will choose 10,000 points randomly and get their position and store their position. You don't want that because some points are now getting lost. So the points that are not included in the random value will not store anything. So we'll have a 0 value. So they will just move to 0. Let me just frame this and let's call it get object to position. And now let's test this. Go back to your switch noise. Let me just zoom in, expand this for a little bit, drag off your switch noise and set it to group input. And you want to go to the side panel and go to group and name your input switch noise or noise switch. And now you want to switch between the rest pose of the monkey and the rest pose of the torus. So the points, when you switch the switch, they will move to the rest pose of the torus instead of going back to a monkey shape. And to do that, duplicate your name attribute for the correction vector and set it to rest pose 2 and connect it to a switch vector node. And you want to connect the switch to a group input and name it switch object. So go back to your side panel, name it switch object or just obj. And now we want to test this. So when you switch the noise on, it gets noisy. When you switch the object, it switches the object. As you can see, some points are just getting scaled down to 0, 0, 0. That's because we're choosing random points to store their information, and some points they just don't know where to go, so they just go to 0. So instead of using the random, we're gonna use a domain size, and we're gonna take the domain of our grid. So we're telling Blender for each point of the grid we want to store their position, and this won't work because their position is already 0, 0, 0, as you can see when I play the animation. And if you want to make it work, you will need to take the points that are forming a torus and connect them to the domain size. If you connect them to the domain size and you set it to point cloud, it will tell you the torus is made of how many points, and you want to connect that to the random max value, so it will get the location of all the points that are forming a torus, but just do that randomly. As you can see, now it works. However, there are 3 or 4 points that are still going to 0. See, inside here. And to fix that, add a math node after your domain size. Get a math node, set it to add, and let's add 3 points. And replay the animation, and there is now 5 points. So you need to subtract 3 points. Now as you can see, all the points are behaving correctly. So they go back to the location they're supposed to be. Now if you go back to your velocity vector and you change the velocity scale from 0.9 to 0.99, this will mean that the points will have or not have, they will keep their velocity longer. So it's like they have more mass. Because objects with more mass, they will have more velocity, so it will be harder for friction and gravity to make them lose that velocity. And if you change the mix factor, it will mix between the velocity and the correction velocity. So giving it a stronger value will make the points correct their location faster. Giving it a small value will make the points don't correct their position very quickly. And after you're done with that, go to the end of your simulation, and you want to use a instance on points to return these points to any object you want. I'm going to use a cube here, so just get a instance on points node and connect the instance socket to a cube. A mesh cube, let's get a mesh cube, and you want the scale to be very small, so 0.05 should do it, and connect it to the instance. As you can see, the points are now cubed, and they are stacked correctly in the right place. So now you need to give these cubes a material, and to do so, we'll use a set material node. Right here I'm just increasing our subdivision to get more points. That doesn't change anything. And every time you use a set material node, don't forget to realize your instance before that. If you didn't realize your instance, you can't use the named attributes that you've made. And it's basically giving all the points the same material and you can't change anything, and it looks horrible. So now get a realize instance node and a set material node and connect them. So just drag and drop. Let me just adjust this line and get another node, set material node, and you want to set material to your material. And now we're gonna store another attribute. So take the velocity and dot product with the position of the points and connect them to another store name attribute after the simulation and call it this for displacement. Now go back to shading and go to rendered view and set your render engine to be Eevee and turn on bloom and ambient occlusion. And you want an attribute node and you will call this so it gets the information of the displacement you've saved. And now we're going to use this attribute to control the color and the emission of our material. So let me just drag this over here and get a color ramp. And what the color ramp do is let us control the fall off and also clamp the value. So the lowest value will be 0 and the highest value will be 1. You want to adjust the colors to any combination of color that you like. Make the color into the color. Let me just preview this. Go to scene light, turn on the world opacity, and turn on the world strength to 0.2, and connect the color of your attribute to a math node. And you want to set the math node to multiply. So you're multiplying, let's just say I'm using 50 here. I'm multiplying the velocity of the object by 50 and connecting it to the emission strength. So each time the point gets a velocity of 1, it will get an emission of 50. And each time it gets a velocity of 2, it will get an emission of 100, and so on. And now as you can see, when the points move, they will emit more light. And you want a color ramp in here. So it just clamps the value. So you don't get negative values, you only get positive ones. And you want to disconnect this color, it doesn't look so good. I will use a different emission color. So take this color wheel and I will select orange. As you can see, now it works beautifully. Now I will change the color one more time to a red. And now we'll go back to our 3D viewport and test this. So noise on, noise off, switch object. That's all you get. So going back to our 3D viewport, if you click tab, delete everything, and add a cylinder, scale down the cylinder so you don't crush your PC. Add 2 loop cuts to support the subdivision surface and replay your animation. It will set the points to a position of a cylinder. And this works with any combination of 2 objects. Now you get 2 switches, switch for the noise and switch for changing the object between object number 1 and object number 2. Once you change the second object, you just go to the second object, unhide its geometry, go to edit mode and delete all the geometry and add a new geometry. Or what you can do is go back to geometry node and pick the picker and pick another object. It's the same thing. And now the tutorial is finished. Thank you all for watching, and I hope you all have a wonderful day. If you like this type of content and you want me to make more, don't forget to like the video and subscribe so you don't miss any new videos I upload. And if you need any more help, or if you just want to chat, I'll put the link down in the description for my Discord and other social media. See you all in the next one. Bye bye.